Hi, here's the math portion of the Unit 1 review. In case you want to see all the problems worked out, let's begin, shall we? How many particles are there in 0.706 grams of a sample of phosphorus? That problem, you're just going to start with what you're given, 0.7206 grams. And you want to get from grams to particles or atoms. So you're going to need two conversion factors. In the first one, use the molar mass of phosphorus, 31 grams per mole. And the second one, use 1 mole on bottom so it cancels, and then 6.02 times 10 to the 23rd on top. When you plug it in your calculator, I'm going to do 0.7206 times Avogadro's number divided by 31. And you got, I want to call it 1.4 times 10 to the 22nd. Particles would be the label. Problem like this tomorrow is going to be 4 points, 1 point for work, 2 points for the right number or very close to it, 1 point for the correct label. Next question is a density question. How many milliliters of ethanol are needed? If you have 15 grams of it, that's what you need for an experiment. Given the density of 0.789 grams per milliliter, use the density triangle. And you want to solve for milliliters as volume, so it's mass over density. Volume equals mass over density. Then plug in, mass is 15 grams, 15.0, and then 0.789 grams per milliliter. And let's see, this has 3 sig figs, this one has 3 sig figs, so I'm going to go with 3 sig figs for my answer. It should be 19.0 milliliters. Next question, how many grams are in a 2.532 mole sample of sodium bicarbonate, NaHCO3? 2.532 grams. This one you can do directly, just going from, moles to grams, moles. 1 mole of that, if you add it up, it's 23 plus 1 plus 12 plus 16 times 3 is 84 grams per mole. So moles cancels out, and you just take 84 times 2.532. Let's see. I'd be okay when you're using roller mass here. You know, you can use as many sig figs as you want, or maybe call it 84.3 if you want to get 3 sig, or sorry, 84.0 if you want to get 3 sig figs. But for me, I'm just going to go with, I'll call it 213. That'll be 3 sig figs. Grams. Next, number 4. What's the final temp? So final temp in a specific heat problem, T sub F equals Q over M times C plus initial temperature. That is going to be, the amount of energy is 500 joules in this question. Mass of the sample is 20 grams. Specific heat of the sample is 0.897 joules per gram times Kelvin, and you add 22 at the end. So do the bottom stuff first, then do this part, and then add 22. So me, I have 500 divided by 20 divided by 0.7 plus, was it 20? 22. So 49.87 has 4 sig figs. This one has 3, this is 4, and 3. So the smallest number is 3. So I take my 49.87, and I'm going to make it into 3 sig figs. I'm going to call it 49.9 degrees Celsius. Molar mass of sodium sulfate. Sodium is 23. There are 2 of those. Sulfur is 32. There's only 1 of those, and 4 oxygen, 16 times 4. All those numbers came from the periodic table. So 23 times 2 plus 32 plus 16 times 4. About 142. Label for molar mass is grams per mole. A density problem number 6. Got a plastic block. It's got dimensions here in millimeters, meters, and centimeters. I want to know the mass, so I'm going to use a density triangle again. I want mass, so it's density times volume. Find the volume first, we'll see how they're all different labels. You want to get them to centimeters because centimeters cubed is the same as a milliliter. So we go with that. And you might want to remember for your test tomorrow, this is the number line, the 3 spots you need to know are kilo, centi, and milli. So base unit in the middle, kilo on the left-hand side, milli on the right-hand side. 110 millimeters then right here, 1 spot to the left is 11 centimeters. 0.3038 meters right here in the base unit. When I get the centi, is 2 to the right, so 3.8 centimeters. And the other one's already in centimeters, so 5.2 centimeters. Multiply those together. 11 times 3.8 times 5.2. 217.36 for your volume. Centimeters cubed times the density of 1.97. And I got 428.199. I'm supposed to have, let's see, what, 2 sig figs. So 428.19. To get to 2 sig figs, because here's 2 and 2 and 2, it's going to be 430. Label here would be grams for mass. And tomorrow's test will also have a specific heat lab question like this one. In that problem you're making use of the fact that all the energy you lose from the metal is equal to all the energy you gain for the water. Or if you want to put it another way, metal energy could be this, water energy could be this. Remember, all these over here are metal, all of these are water. Might help to just kind of go through and put where everything goes, like label it, like this is specific heat of aluminum, so that's a C for metal. Specific heat of water is C for water. Mass of the water is M. Initial temp of the water is Ti. Final temp is Tf. Initial temp of the metal is Ti. And that's where all the variables go, and I just plug them in. We're solving for the mass of the aluminum, so that's going to be this variable. Specific heat of the aluminum is 0.897. The initial and final temperature of the metal, see, the initial temperature was 98.8. Final temp of the metal was 29.3. And set that equal to all the water numbers now. The mass of the water is 55.3. Specific heat is 4.18. And the water temperature change was 19.5, and it went up to 29.3. So 29.3 minus 19.5. Okay, got to simplify a little bit here. So negative m equals 0.897 times 29.3 minus 98.8. Negative 69.5 equals 55.3 times 4.18 times 9.8. At this point you could recognize that, you see, this negative and that negative will cancel out. Or you can wait till the end, it's up to you, but either way you gotta divide both sides by 0.897 times negative 69.5. I'm sorry, positive would be fine here. So then m equals all of that mess here on the right hand side. You can see this, it would be 55.3 times 4.18 times 9.8 divided by 0.897 divided by 69.5. You got 36.337. Let's see. I think all of these are 3 sig figs, so 36.33 just becomes 36.3, and the label here for mass would be grams. So you see one of each of these kinds of problems on tomorrow's test. Good luck studying. Bye!